So I'm Taylor. You good? Okay. So over the winter break, I needed a diversion, so I kind of took some of my Arduino kind of messing about and thought, what can I do with JavaScript? And it kind of as an apology for the JS Meetup, most of my JavaScript is in CoffeeScript. So, you know, if you need a little explanation, or I can talk things through a little bit more if it doesn't make sense. But yeah, I'm sorry about that. So, what am I talking about? So what I wrote was kind of a temperature network for my house. I've got 3 different temperature sensors. I got one upstairs, I got one downstairs, I got one in the garage, and I have one outside. I've only got 2 of them running right now. But I've got that temperature network hooked up to a Raspberry Pi, and NodeJS is reading that temperature network, and then it is also saving those values to a database so you can do interesting stuff with it in D3. And it's also updating whatever clients are attached to it in real time. These numbers down at the bottom are the kind of the temperature readings of the different sensors I have out there. So that's kind of what I built. So I'm going to kind of run through what I took to build it. So I'm going to try to touch on a little bit of the hardware, software, environmental aspects of it. Which is probably a little different than a lot of other demonstrations because, mostly it's just JavaScript. So I'm not an expert in any of the electrical engineering kind of stuff. So don't really know what I'm doing, but it's worked out okay so far. But it can be problematic. So what I did to build that was Raspberry Pi, some sensors, and then some stuff to kind of wire it up, Cat5, breadboard, crimpers, multimeters, all that kind of good stuff. So if you haven't, I'm hoping you guys have kind of messed about with the Raspberry Pi, but it's like a credit card sized computer. Looks a little bit like this. It's $35. Has an ARM core on it. Runs Linux. They're cheap enough that you can kind of use them willy-nilly and mess about with them, not worry to break them. It can do 1080p video. It can do a lot of different stuff. It looks like, here's a bigger picture of it. You guys can see it. It's also got a USB hub, so you can hook up USB sound cards. It's also got a built-in sound card. It's got HDMI out. It can do a lot of different stuff. There's a jumper on there. You can do video cams that are designed specifically for it. Really, your imagination is kind of the limit of it. So, but one of the other things that I really focused on was these pins right here can be kind of hooked up straight to the ARM processor, which is probably both dangerous for the processor, but if you put too much voltage through it, you can kill it. I believe it's a 3.3 volt system, and most sensors are that, so usually it kind of works out. But if you do the wrong thing, you can kind of blow the processor, I think. So my wire network hooked up to some of those pins, and there's some Linux kernel drivers you can use to kind of do some bit banging on those pins to simulate the different network protocols, kind of think of the different kind of hardware interfaces to talk to those sensors. So that was kind of an overview of what that is. So the OneWire sensor. So what the OneWire sensors are is these little different super cheap devices you can buy for $2 to $4 a device, and there's generally 3 wires on it, 3 inputs to it. It's called a OneWire network. The reason why it's called OneWire network is there's one wire that's data, I think, and that data also carries the voltage. So there's ground, data, and then if you run it in a parasitic power mode, you only need 2 wires, but 3 is a more reliable network. So a 3-wire, 1-wire network. So you got ground, voltage, data. That's kind of how I have mine wired up. Does that kind of make sense? So, I might make a little bit more. So here's kind of a blow up of that pin block on the Raspberry Pi. And so all these different pins are kind of available to do different types of kind of hardware-based talking to other kind of devices. So here's kind of what that temperature gauge is that I have hooked up to. It's hooked up to the, it looks like it is 5-volt base. Hooked up.
Is that the power supply?
Yep, so that's, you got your voltage pin, and then this general purpose IO 4, which is kind of the Linux kernel driver that's in there, expects it to be on that pin, ground. So that hooks up to your sensor, and it also requires a resistor, and that is because you can have it in a parasitic power mode. 0, I think, is actually positive, like full voltage, let's say. So it's always drawing a little bit of current. And then that looks. So this is what it ends up looking like when you get it kind of wired up. Sorry for the crappy picture. So I've got kind of a breakout board which allows me to take those pins and put it on a breadboard, and a breadboard is kind of an easy way to kind of rapid prototype different kind of circuits. So once I've got that over on my breadboard, bring that over to some Cat5 cable that then goes through my house and connects to all these different sensors. This diagram does not show that very good. This picture does not show that very well. So that's kind of where it interfaces with the breadboard, and it kind of starts the build out.
So you had to wire the resistor in on the breadboard?
Yep. Yeah, it's in there someplace.
I don't see it.
Can you scroll the right or is that the end of the page?
Well, let me scroll right.
If only you had more resolution.
Yeah, so if we go back, so I mean, it's in there someplace, right? So instead of having, that sensor attached directly, right? We've got Cat5 that stretches it way out. You only need one resistor on a 1-wire network to pull that voltage on there. But it is needed. So 1-wire network, we've talked about a little bit. It supports kind of a serial, so you can kind of chain them off, the different sensors off each other, and you can also do kind of a star topology. So, and then you actually have the hookup to the sensor, and the sensor looks like the wrong picture. Good picture of the sensor. It looks like kind of like, I forget what you call them, almost like an integrated circuit, pretty much. This is the other side. So what I did to kind of wire up the network is I ran Cat5 and I terminated the Cat5 with some RJ45 sockets. I only hooked up 3 of the wires in the socket, and then on the RJ45 connector, I've also got 3 wires, and that extends out to something that looks like this, which is kind of a piece of PCB that's soldered to the sensor. I just and then soldered it up, and that's just for reliable electrical connections, so that everything can kind of talk to each other. So we're talking about a lot of different hardware things, but the interfaces and everything is so abstract. Like you can kind of think of it as like your typical computer network in a lot of ways. And so by having this sensor hooked up to kind of a serial topology OneWire network, and then having that back to my Raspberry Pi, you're kind of building a network of sensors.
So the sensors are raw connected to the Cat5.
Yep. Well, yeah. So I've got it hooked up to this PCB and wired up, and then I've got I should have brought one in.
The other end is the Cat5.
The other 5 terminates with a Cat5 connector, and then I plug it into my network using a RJ45 socket. So it's, but it could be straight up wired. I just wanted a little bit of flexibility, and I guess I wanted a challenge when the connections went wrong too. More places to look for problems. And that kind of go back to the hardware list, right? I had a multimeter on there, and when things go wrong, multimeter is very helpful for figuring out if you got connectivity on something or not. So these sensors, they are there's a lot of different ones available. So the temperature sensor is this guy right here, and you can look at it. There's all these fun little things, and so you can look at which wires do what. I'm not a hardware guy, so this was novel and unique for me. And it's also fun because, if there's not a driver written for the sensor you're using, you have to look at these tables and different voltages and everything else and kind of reverse engineer it till what you're expecting to come out of the sensor starts to look like what you want. I had to, or find another sensor that's not written in JavaScript, and then try to translate the logic into JavaScript. If you can get kind of like a text-based interface to it, so here's so if you wanted to write your own driver from scratch, you start to get into this kind of stuff.
So did you find a driver, or did you write?
I found a driver. So the software to kind of talk to this hardware-based network. So you got your Raspberry Pi, you have a Linux-based distribution on there. Raspberry Pi, the biggest distro I've seen is Raspberry, which is Debian-based. So
Raspbian's also a big one.
Raspberry.
That's what you have on there.
Okay.
Yeah.
Sorry. Yeah, actually, that's what I'm using. And then once you've got that right, you want to do useful things on it with Node.js. So I put on Build Essentials, which allows you to build some of the binary-based Node packages on Raspberry Pi, the Avahi daemon, if I pronounce that right, so that you can kind of discover, you don't have to set up a complex network. You can find your Raspberry Pi in your network pretty easily using, DNS names instead of IP addresses and that kind of stuff. And then Node.js actually comes pre-built for ARM. But you got to go find it. They don't build it for every minor version of Node.js, but if you hunt around enough in the other downloads, you'll find a build that'll run on Raspberry Pi, believe it or not. And then your favorite development tools, which for me is Emacs. So once you've got your build environment set up, so here's the kernel drivers to read, to simulate that bit banging on those pins on the Raspberry Pi to talk to the OneWire network. And there's also a specific driver for the OneWire device, the OneWire therm. So you insert those drivers into the kernel, and then what you get is devices So what you end up is some devices in your sysbus, I guess, and they're just, it's interesting, I got 3 devices in the network now. So one of the devices started working again. So I got this folder with some different files in it, and I can inspect it. So OneWire slave, I think, will give me a reading off there. So that just took a reading off of the network, outputted it as text. So that's kind of like, now I've got it in the software space. Now I've got it as a text file. Now Node.js can go and attack it and do useful stuff with it. And so that is where the software stuff comes in. So now we've got, something we can use in Node.js. So what I did is I wrote an little Express app. So that does two things. So we've got an HTTP server, and then we've got a loop to go and read those sensors every 60 seconds. So that is here. So we go read each one of those files I showed you. So for the different sensors, figure out whether or not it was an okay reading, and then calculate the temperature in Fahrenheit because it reads it off in Celsius. So if we take a look at
What was it? You said it was a good reading. It was an okay reading.
Yep.
Does you get sometimes get garbage in there, or?
yeah, so see at the end there's a CRC equals 49.
Okay.
So it does like if we look at that PDF, there's some sort of, I forgot exactly what it does exactly, but it does do some like error correction on there. And it does happen occasionally. Like if you've got a bad part of your network or a bad connection or something, you might start to see CRC errors. Or I didn't really look at like what if you looked at how I soldered up like that end bit, I've got a decent length of straight wires, and Cat5 I think is supposed to have twists to it and everything else to create the perpendicular fields, B fields or whatever, going back to my physics days, to create a stable connection, and that might not be in spec. It might take up some noise. But yeah, so the T equals 21,000. That is the temperature reading. I think that's in Celsius. I think it needs to be divided by 1,000. Or I got a couple of lines the house is on fire. So I've got a list of sensors up here. And we just go through each one, read it, and then dump it into a SQLite database. After we get that, we also use socket.io to let anyone else who is interested about our new temp readings, and then they can update their content. So here's our Express server, right? So we serve up a couple URLs that return either the current temp or the temps we're interested in. I had a power outage at my house on Friday, and I forgot I was giving this talk I didn't forget I was giving this talk, but I didn't test any of this until maybe an hour before coming here, so I didn't have any useful data in there. So after a little bit of panicking and some SQL querying, I figured out an interesting time range where there was actually stuff going on. So we return all the temps we know about. So that gets dumped into a D3 app, and this was actually probably the main point of all this, I think, for me, was I wanted to mess about a little bit more with D3, but I did not actually do a whole lot of that.
A roundabout way of doing D3.
Yes, well, and I'll talk a little bit more why I don't have. There was some learning experiences or opportunities with this project, which is one of the reasons why I do not have that much time with D3. So in D3, we go and get all of our temperature readings, and then we build a graph around it and display it, and then we also create a socket.io guy that listens and kind of shows the current temperature. So that's this bit down here. And it does, update over time. And unfortunately, now that we don't have our Arctic blast, it doesn't really change a whole lot as much as it used to. That was interesting to watch it.
So how often are you gathering
I think every minute. Yeah.
So if you get a record that has that error marker on it, do you re-pull it, or do you just wait for the next minute?
I think I just don't log it, don't send it, and then things don't update it. So there'd be a hole in that record, and it looks like I'm kind of normalizing it so each reading, even though each reading is at the same time, it's a new line. So here's, the D3 stuff was interesting. I wanted to do more with it. But, so if I go back to, so why I didn't get to learn more was after having that run for a while, I discovered that the Raspberry Pi uses an SD card. It's kind of like hard drive. And those SD cards are flash-based. You're like, oh, flash-based, we got SSDs now, right? Should be good. Well, after it died, I learned you only get about 10,000 writes on SD cards before they start to have failures. SSDs, nowadays you can do millions and millions of writes, not have to worry about it. So, not looking at what SQLite's I/O model is, data logging I think before that I had it down to 30 seconds. It quickly used up 10,000 writes. Nuked my card, and I had not pushed my Git repo I had on there in a long time, so so I had some catching up to do. This OneWire temp, I've got all callbacks in here. At one point, I had this all promisified. I lost all my promises and stuff like that. I also think I had some more fancy features in the client-side stuff, which was, I think it updated the graph in real time too, and just the bottom. I think something else I had. I lost all that, unfortunately.
So you actually built this on, the development environment with your Raspberry Pi?
Yep. Yeah, so these files I'm editing right now are actually the Raspberry Pi that's doing this at my house right now.
Is there a simulation environment so you can do this on
Well, so when I said favorite development tools, right, I said, well, Emacs is mine. So with Emacs, you can do tramp mode, right? So I'm accessing the files on the Raspberry Pi right now. I can, if I want to change them, so I can go in here, let's, here, I'll change this back to what was originally there. So now it's dynamic. We can pull how much time we want to go.
The other thing is once you connect to Raspberry Pi to the network, you can SSH it to your machine and do it when I do development on my Raspberry Pi, I just do it on this machine. And I just tunnel in. It's so much easier than trying to navigate this. It's there might be a half-second delay because you're tunneling in, but it's not the end of the world.
Is your Raspberry Pi grunting right now?
No, it's not grunting. But so if you look at the file location, I'm using Emacs tramp mode to actually double hop across my house, my home network, grab those files. When I write it, it writes it out over SSH. And then I've got just a session up, and I can.
But isn't the question isn't it like developing on your production server?
Yeah, it is. Yep, and I do know better. But the nice thing about how so they're $35, right? So if you did get serious, you can always have another one like that. And if you wanted to simulate those drivers, all you have to do is simulate a text file, right? You have to put some files that look like that, probably.
So would one of your future features be to not write it to the SD card, to basically post it to a REST service or something?
Yeah, if I were to, as I were, so yeah, part of my thought process is making this was, do I want this like self-contained? Do I want it going someplace else? Originally, I thought I was going to do it over Wi-Fi, but I did actually manage to get my Raspberry Pi hooked up to a wired connection. But doing it over Wi-Fi, I was going to try to avoid like logging out to a remote database. But now that I've got a wired connection, I think I would probably try to do some like real-time, like different Node.js talking to each other, maybe pushing it, kind of pushing it out to another server that logs it and serves up the web front end. But it was also kind of like how far can you take a $35 device? How fast does JavaScript run on an 800 megahertz system? Like.
Can you install MongoDB on Raspberry Pi and then get like 10 of them?
Yes.
I don't know. That might be a bit much. But so like when I bring
lose any data.
Somebody ran Hadoop on a cluster.
There you go. Problem solved.
So when I bring like this up, so the Raspberry Pi is compiling CoffeeScript, which is not trivial, and I've got middleware-wise set up too. It's also every time I request it, it's compiling this CoffeeScript into JavaScript for me in real time. So as I edit this, it's building new JavaScript versions through the Connect or Express middleware that my client can download and all that kind of good stuff.
Yeah.
As far as like how I addressed, the SSD write problem, so I mounted that SQLite database up in memory. So now I'm writing to a memory location, and then I set up a cron job to copy that out every hour or something like that. So that's not just a memory. And I haven't really researched what the coherency model is for SQLite yet either. So I could be doing bad copies, or non-coalesced copies, I'd say. But so far, hobby project, it's working well, and I haven't killed this SD card yet, which is nice.
So you're talking about, your power died.
Yep.
And you blew, so obviously it stopped. I literally today subscribed to a Kickstarter project for an uninterruptible power supply for a Raspberry Pi. So, but the thing is, it costs like 3 times as much as the Raspberry Pi.
Well, and they don't actually use that much electricity either. I think you can like run it off like a 1 amp USB connector, and folks take things like 8 AAAs and like hook them up in the right order and power Raspberry Pi for a couple hours, maybe. I bet you could probably, if I was smarter about that kind of stuff, I could probably figure out some sort of system to do that. I do have UPSs at my house, as I never really thought to put the Raspberry Pi in one, though. So, things I use to kind of pull this all off. Adafruit and SparkFun were definitely useful as far as buying parts. They've got like tutorials out there. Some of the tutorials are more,